What's up, everybody? It's Hutch, and today we are going to start our Module 6 on algebraic expressions. It's a pretty short module. Let's go ahead and jump into it. What will you learn? Simplifying algebraic expression. We're going to use distributive property as well, all in this first lesson. And then we have adding linear expressions, subtracting, finding the GCF of monomials, and then factoring and simplifying linear expressions. So all of that, some vocabulary that you may be familiar with, but probably some new ones too, like coefficient, and then factored form of monomials and things like that. All right, we're going to start off with just a review, something that you've been doing probably since 3rd or 4th grade. They're getting increasingly more difficult, but still something you need to revisit. So this section is called translating. Okay, and basically it's taking this word form and turning it into standard form. At this point, we don't call it that. We just call it translating. All right, now we're going to start off with the subtraction, and I want you to write down up here that these are called switch words. In subtraction, a lot of them are nice and simple. Like, for example, number 1, 11 decreased by a number. For the variable for number, we're just going to use n. So we have the number 11, and it's decreased by a number. Okay, so that variable. We have a number minus 4, nice and easy, a number minus 4. Order matters with these. Okay, so make sure that if you can put it in order, that you do put it in order. Otherwise, it'll be wrong. The only exception is something like row 2 there. So let's go ahead and do number 4 real quick. The difference of x and 4. Remember, difference means subtract, and so you may want to make a note of that. So we have the difference of x and 4. So we have just x minus 4. Okay. All right. Now, the ones to pay attention to are in row 2 here. So we have 8 less than a number. Now, when you have less than, this is one of your switch words, okay? So pay attention to that, okay? Because if we have 8 less than a number, we're talking about an original number. So that means the n has to go here, and we have 8 less than that. If you did it the other way around, it would be starting with 8 and taking n less than that, and that's not what this is. The other switch word is going to be from, okay? So just make note of both of those switch words, okay? So subtract 4 from the original 6. We have 6 minus 4. So those are the two to just pay extra close attention to, is less than and from with subtraction. All right, let's talk about grouping. We have double the sum. So think about what double means. Double means times 2. And then the sum is addition, and so that's going to be represented with the and there. So we have double the sum, or double the addition of 12 and p. So I want to get my 12 plus p written here, and that's going to be grouped like that. Now we want to take double of that, and so I'm going to put that in front because that's the order, okay? And remember, order matters. So double the sum of 12 and p. All right, the next one, we have 3 increased by. I know that that's going to mean add. We're just increasing. Quantity is a word that means parentheses. So we have the quantity of p minus 5. There's no switch word there. And so we end up with 3 increased by the quantity of p minus 5. Okay. All right, now let's go ahead and look at multiple operations. So we have the difference. We know difference means subtract. Quotient means divide. So we have the quotient of 3 in a number, comma, and 4. So you have to sort of process this and pay attention to the mechanics with the comma there. The difference of what things? So the difference of the quotient of 3 in a number and 4. So I want to take the difference of those two things. So here's where my subtraction symbol is going to go. Okay. Now the quotient one, the quotient of 3 in a number, quotient means divide. So we're going to go 3 divided by a number. And then we're going to subtract 4 to get the difference. Now, because of order of operations, I don't really need parentheses, but I can. Okay, let's go ahead and do a squiggle here and write this another way. Remember, we can use fractions as well. So 3 over n, and then minus 4 is the same thing as the quotient of 3 and a number minus 4. Okay, all right, let's go ahead and take a look at number 8. We have 5 taken away from. So there's our switch word, okay, for subtraction. So that means 5 is going to be at the end. Okay, 5 taken away from this thing here, product of 6 and a number. Product means multiply. Okay, so we have 6 times n. I could write it like that. We could also just write 6n. So the product of 6 and a number. And 5 is taken away from that original thing. And there we go. Okay. All right. Let's go ahead and take a look at some use of rational numbers. We have half of a number written as multiplication. So half of means multiply. So 1/2 of a number. So I could do times n, or I could just do n. Okay. Either way is fine. If you want to write them both, you could do that. Okay. All right. Now that same thing as division. Okay. So remember that 1/2 times n is the same thing as n divided by 2. Okay. Because really when you're writing 1/2 times n, we're writing n over 1. So you can see if I multiplied this all straight across, I would just get n over 2. Okay. And so that's why that works that way. Okay. All right, a fourth of, remember of means times, so 1/4 of, and then there's this other stuff, the sum of 20 and a number. The sum means add, so 1/4 of, which means times, 20 plus n. Okay, what would that be as division? Well, remember, 1/4 times is the same thing as just divided by 4. And so we could have, because this would be over 1, right? Same thing as the other example. So we could go ahead and just write 20 plus n over 4, or divided by 4. Okay, and I don't need parentheses in top because numerators are invisible parentheses. All right, so that's just a little review there. Let's go ahead and get into our actual lesson today. Okay. I can simplify algebraic expressions. So you need to know a couple things, okay? We have these things called like terms, okay? And you have to understand what like terms are. Like terms mean that they have, they're in the same club, okay? So they contain the same variables. They are to the same power. So for example, this 3x squared means you have 3 of the x squared and you have -7 of the x squared. They're part of that x squared club, okay? Y cubed and y to the 4th, though, are not in the same club, okay? They have different exponents. So they have to have the same variable and they have to have the same exponents, or they have to be just a number, okay? And that's called a constant. Okay, so you have a couple other words to be aware of. So we have a term, just means this entire thing between the operation. So there's 1, 2, 3 terms. Okay, that's what those are. Okay, and then the like terms are the ones in the same club with each other. Okay, so the x club or the y squared club, or if there's nothing attached, it's just numbers, they're called constants. Okay, so those are our vocabulary to be aware of. So let's go ahead and sort into appropriate bins or clubs. So you have to look. So this is the x squared club. Okay, this is the x club, and this is the constant club. Okay, so find all the x squared clubs and put them in here. Okay, so I see I have -9x squared. I'm just looking for x squareds. The constant in front tells me how many of them there are. Okay, so that one's gone. I have a 30x squared. And that's it for that. So now find all the x club. Okay, so this one is everything in the X club, and it's X by itself, which is really X to the first power. Okay, so go ahead and you can pause if you want or follow along. So I have an 8x and a negative 1.5x. And then we're looking for, oh, and there's a 6x as well. And now we're looking for the constant club, which is just the numbers. Okay, with no variables attached. And there we go. Okay. All right, so now we're getting into the first learning, which is combining like terms. Teachers will teach you different ways. Some teach this castle method, which is where you look at this. You basically separate all the terms out like this. Okay. Because you have the iPads, I really find it easiest to highlight. So that's what we're going to do today, is go through that process of highlighting. So let's get some nice colors to highlight here. That's a little bit bright. Maybe there's some more faded ones over here that might be better. Okay, so what I would recommend doing is just start by highlighting the first club. So there's the N club, and then I'm going to go through and look for all the other N clubs and highlight them, but you need to make sure that you include whether they are positive or negative. So another recommendation for you, if you want, is you might want to go through and KFC everything, okay, so that you're looking at all the terms separated by addition, okay, because this is going to work when we have addition in between. Subtraction really is addition because you can KFC. Okay, so now I can go through and I can highlight all my N club. Okay, and you can see how that's a little bit easier because I KFC'd. I'm highlighting everything in between the plus signs. Okay, so let me get the next one. Here's my constant club. Okay, and you need to make sure that you get that positive in there. Okay. All right. So here we go. Now I can go ahead and write them down. So I have a 6n and a negative 8n. So you still have to sing your song. Different sign, subtract. Keep the sign of the bigger number. Then you'll be exact. So I have a negative 2n when I combine those two. And then I have a plus. And then I have a negative 1 and a positive 9. So we have 8. Okay. And this is my final simplified expression. Okay, so let's go ahead and take a look at example 1 now. The cost of a jacket, which we're representing with J, that's what that means, after a 5% markup can be represented by the expression J plus 0.05, because we know 5% can be written as swoop, 0.05. So 5% of something means 5% times, and in this case it's J. Okay, so that's just a little side note that you can just have off to the side. So let's go ahead and simplify this expression. We have J plus 0.05J. So think about how many J that really is. Okay, I would recommend when it doesn't say how many, like the constant in front of this variable is 0.05. It tells us how many J's we have. How many J's are here? Okay, this is actually an invisible 1, right? It's 1J plus 0.05J. So if we combined like terms, okay, we would have 1.05J. And we know that to be true. 5% markup, remember the trick is to just take 105%. And that's what that is. Okay, is 1.05J. Okay, so increase the jacket's price by 5% is the same as multiplying the price by 0.05, or after we solve it all at this point, we can just multiply the whole price by 1.05 or 105%. So suppose the original cost is $35. What is the cost of the jacket after a 5% markup? So we would have 1.05 times J, which they're saying the jacket cost is $35. Okay, so if we mark that up, we have 35 times 1.05. and we have $36.75. Okay, so that's your process. So go ahead and try this one. You can pause and try it on your own. The cost of a new pair of shoes after a 3% markup can be represented here. We know that the trick would be to just find what 103% is, which is what we're going to get here. So let's go ahead and simplify this expression. I'm going to put in the invisible 1 here. So if we combine like terms, we have 1c and 0.03c. So we have 1.03c is our simplified expression that would solve that situation. Okay, all right, and there we go. Go ahead and highlight it or circle it or whatever and move on. All right, let's go ahead and practice combining like terms. You can see we have quite a few more terms now. Okay, so my first recommendation to you was you can either KFC everything and go through so that it's easier to highlight, or the other option for you is just be really careful and make sure you're always highlighting the symbol with the constant and the variable. So I always start at the beginning, okay, and I have an negative 5x, so this is the x club. So go through, do I have any other x clubs? Nope, I don't, okay? And so right away I'm just going to write that I only have a negative 5x, and then put your plus sign. Okay, this is another big thing. You cannot forget to put the plus signs in between each of them. Okay, this is an expression and we're adding the different terms together. All right, let's go ahead and grab the next one. So this is the y club and I have a positive y here. Are there any other y's? Yep, there's a 5y and it's a negative 5y. So you make sure you include all of that. Okay, all right, so I'm going to go ahead and write down how many y clubs I have. So I have a negative 5 and a 1. Different sign subtract, so I actually end up with a negative 4y. Okay, and then my last one, I'm gonna go ahead and put the plus sign in between. Let's get our next club. Pick a really different color. We have a positive 6 as a constant. Here's my other constant. So I have a positive 6 and a negative 3. Different sign subtract, and so we end up with a 3 at the end. So negative 5x plus negative 4y plus 3. Okay, all right, and there's our simplified. So go ahead and pause and you can try the next one and then play and you can see how you did. Okay, so first I'm going to do this one by KFCing everything. So plus negative, add the opposite. Okay, so there we go. Let's go ahead through and highlight. Here's my constants. There's a positive 9, and then there's no more there. So I'm going to go ahead and write those down. So 9 and a negative 5, different sign subtract. So we have a 4 plus, let's go ahead and find our next one. Okay, we have a negative 3w, so it's the w club. There's a positive 8w. So let's go ahead and write that one down. Different sign subtract, 8765w. Plus, and then let's get the last club member. We have a negative 6z and a negative 4z. Same signs, add and keep. So we have a negative 10z. Okay, and there's my simplified expression. Okay, and then you could more easily plug in variables and things like that. All right, let's go ahead and expand linear expressions now. Expanding is another word called distributive property, okay, or distributing. And so what we're doing is we're allowed to distribute when you have a quantity with addition in the middle, or subtraction, because remember, subtraction is just adding the opposite. So it really is addition, okay? And so we have a number that is being multiplied to both of these pieces, okay? So it's 3 times x plus 3 times negative 5, okay? And so that's what distributing means, and we need to do that in order to expand the linear expression so that we can then simplify it, okay? So let's go ahead and take a look I'm not sure what that is right there. We'll ignore that for right now. Let's fill in the boxes to model the distributive property, okay? And so the first thing that we would do is I always want you to draw these little arcs here because it's really easy to forget to multiply the second one. So we're distributing the multiplication, and so we would have 2 times x plus, okay, 2 times 2. Okay, and so that's really what you are doing when you distribute. Okay, and so we end up with 2x plus 4. Okay, and so you don't need to do the first step. You can just in your head go 2x plus 4 and write it down. Okay, so let's go ahead and take a look at this. We know we're simplified because there's no like terms and there's no parentheses. And so that's another thing to realize with simplifying expressions. Simplify means there's no like terms and there's no parentheses. You have to get rid of it all. All right, so we're going to go ahead and use the distributive property here. Okay, so step 1, I said draw your arcs. Okay, and we're multiplying or distributing out that 4. Okay, and so instead of writing it separately here, we can just go ahead and do the distributive and simplifying all at once. So 4 times negative 3, okay, is negative 12x. Okay, so it means I have 4 of those. That's all we're doing. So I have 4 of the negative 3x, so I have negative 12x plus 4 times 6 is 24. Okay, so if you wanted to write it up here just so you have it for the visual example, this is what it would look like to distribute. Okay, but you can sort of skip that step and just go to the simplified. Okay, so go ahead and pause and try this one out. We have a 9 times the quantity of a term plus a term. We can do it because it has addition inside. So always do this real quick. It doesn't take that long. And so we have 9 times negative 5a. So if I have 9 of them, how many do I have? I have negative 45a plus, I have 9 of the 3b, so we have 27b. Okay, and there we go. There's no like terms and there's no parentheses. Now, distributing over subtraction is the same thing. The very first thing you're going to do is rewrite the subtraction as addition by KFCing. So add the opposite. There we go. And we have exactly what we just did. Okay. So for this one, let's go ahead and write it out. So step 1, we rewrite subtraction as addition. So instead now we have plus a negative 5y. Notice it's okay to have the 3 on the right. We still can distribute that. Okay. So go ahead and show your distributive arcs there, okay, showing that you're distributing the 3 out, okay, and we can go ahead and multiply this out, okay, and so we have the 3 times negative 5y, and so if I have 3 of those, how many do I have? Okay, I have 15y, but it's negative. Okay, so we have negative 15y, and then we have 3 times 2x equals 6x, and it was addition in between. Okay, so we have 6x plus negative 15y is the distributed form. Okay, and there we go. And then it says rewrite using subtraction. Okay. And so a lot of times what we do, the more appropriate way at the end is to put it back into the subtraction form like that, okay, rather than having the plus and negative, because it's not appropriate to have 6x plus in parentheses negative 15y. And so that's what this means right here. Okay, so this is really the final answer that we need to have. Okay, so that's one little twist with the subtraction. All right, use the distributive property. Let's go ahead and expand this out. So draw your distributive arcs here. Okay, and so do the multiplication. We have 5 times 7, but before we do, always KFC that. Okay, so 5 times 7 is negative 35 plus 5 times negative 4 is negative 20. W. we wouldn't ever have this parenthesis, so you need to change it back to minus 35. Okay, and this is your final answer. Okay. All right, let's go ahead and distribute negative numbers. Same idea, you're just paying extra attention to your integer rules. So KFC, because we have the negative. Okay, and so we have negative 5 times 2 is negative 10x, plus negative 5 times a negative 9 is a positive 45. And there we go. We don't have a sign next to a sign, so you're actually good to be done. Okay, we don't have any parentheses. All right, go ahead and pause and try this one out, or you can continue to follow along. Okay, there's no negative they have to worry about in between the quantity, so we're just multiplying. So 6 times 8 is 48. Negative times a negative is a positive. So I have 48y plus negative 6 times 10 is negative 60. I need to, because I have the signs like this, okay, I have to change it to subtraction and just write minus 60 here as a final answer. Okay, so it's not a huge deal, but it is more proper to be doing it that way. So I want you to push yourself to always remember to do that. All right, let's go ahead and do your apply part, and then we'll head over to the homework. Okay, the side lengths of two triangles are shown. Represent the perimeter of each triangle with an expression in simplest form. Which triangle has the greatest perimeter if x was 3? And would that still be true if x was 2? Justify or basically prove it. All right, so we know perimeter, peeing around the perimeter. You start on one side and you go all the way around the triangle. So basically that means we have a 10 plus a 4x plus 3 times the quantity of 4x minus 5. Okay, so that's what we have for that one. For the other one, we have an 11 plus 3 times the quantity of negative 2x plus 9 plus the last side, which is 5x. Okay, so we need to go ahead and simplify these so that we can easily solve. To do that, remember, we need to get rid of all parentheses and we need to combine all like terms. So step 1 is going to be to distribute. Okay, so we're going to do that with both of them. Okay, and you can see that I need to do a quick little KFC here to get my work started. Okay, so we're going to have our 3 times 4 is 12x, plus 3 times negative 5 is negative 15. Okay, you can keep it like that for right now. Let's go ahead and bring everything else down because we work in layers like this and you have to really organize your rows. All right, let's do the next one. Okay, so we have 3 times negative 2 is negative 6x, plus, don't forget to multiply the next one, 3 times 9 is 27, plus 5x, and then we need to bring down our 11 plus over here. Okay, now it's time to combine like terms. Okay, so I have my constants here. We can do it over here while we're going. There's my constant there, my constant there. Always include the symbol in front. Okay, and then let's see. I like to write them as I go here so I don't get lost here. So I have a negative 15 and a 10, which puts me at a negative 5. I have a 27 and 11, so 27, 37, 38. Okay, let's get our next like terms here. So here's my x club, positive 4x club, positive 12x club. I have a negative 6x club and a positive 5x club. So let's go ahead and finish it off here. Remember, addition goes in between. You can't just write the numbers. So 12 plus 4x is 16x. And then the other one, we have a 5x and a negative 6x, so we end up with a negative 1x, okay? I can't have this situation, so really we just have 38 minus 1x, or just minus x. So these are our simplified expressions that represent the perimeter of those triangles. So for this problem, they're saying, hey, which triangle has the greatest perimeter if x equals 3? Well, let's just go ahead and plug 3 in. Okay, so we're substituting a 3 in there, and we're substituting a 3 in there. Okay, it makes it nice and easy. Okay, so let's go ahead and do that math work here. Okay, so this is x equals 3. I'm just putting it in parentheses there. So we have 16 times 3 is 48, and then plus a negative 5 or minus 5. That puts us at 43. Okay, so p equals 43. 38 minus 3 is 30. P equals 35. Okay, so which triangle has the greater perimeter? Triangle 1 has the greater perimeter. Will this be true if x equals 2? Well, obviously we're using the same number for both, so it's proportionally adjusting it. But if we have to justify and prove it, we could. So we would just plug in, annoyingly, the 2, and we would do 38 minus 2, and we would get p equals 36, and we would get 16 times 2 minus 5. We would get p equals 27. Okay. All right. So, actually, look at that. That's not what we expected here. All right. So, which has the biggest perimeter? Which triangle has the greater perimeter? If x equals 3. If x equals 3, triangle 1 has the bigger perimeter. If x equals 3, if x equals 2, let's see, will this be true if x equals 2? So no. If x equals 2, triangle 2 has, unless I mess something up here, 16 times 2 minus 5, 27, has the bigger perimeter. Okay. All right, so there we go. Answered and justified. All right, let's go ahead and head to your homework. Okay, 6-1 practice homework, and we'll go through some of these together, and then the rest will be on your own for you. Okay. All right, so the cost of a set of DVDs after 25% markup can be represented. We know when we're doing markup, we're doing 125% instead, okay, to just get the answer. There's the expression that represents it. If we simplify it, we are joining 1c plus 0.25c, which gets us 1.25c. Okay, so there we go. Same thing with this one. We have the cost of a toy after an 8% markup. So we have the cost plus the 8% markup. If we join those together, figure out what you would get. Okay, homework 1. All right, let's go ahead and simplify each expression. You must highlight like terms. You don't have to KFC everything. Not everyone likes to do that, but you do have to highlight like terms. So here's my Y club. Okay, I'm going to get my other Y club with the negative. Okay, and so that's all I have for Y club. So we have a negative 16y and a negative 1y, that invisible constant. So I have a total of negative 17y. Let's get my next club member here. So positive 9z and a negative 25z. So 25 minus 9. Minus 10 would be 15. So we're just at negative 16. So we have plus a negative 16 z. And then our last one is that constant. So we just have 1 by itself, so it's just plus 4. Okay, if you want to double check because you don't want to, trust your math, then be doing your calculator to make sure that you're accurate with that. You don't want to make any silly mistakes. Okay, now remember that technically we would put parentheses around here. So to finish it off, we need to make sure that we're simplifying it by only having one symbol between each term like that. Okay, and so that ends up being my correct answer. All right, I'm going to go ahead and do number 4 together with us. So let's highlight like terms. So here's the Z club with a negative 9Z. And then we have an X club and no other X's. And then I have a negative 5 constant and a 2 constant. So let's go ahead and write these down now. So 8Z and a negative 9Z is a negative 1Z, or just negative Z. We have the X club, which is just a plus X. And then we have our constants, which is negative 5 plus 2. So subtract 4, 3, and we have a negative 3 left over. So I could put plus the negative 3, but I know that I need to keep it end up simplified, which will be no parentheses. Okay, so we have a negative 3 as our final constant. So there's our simplified one. Okay, let's go ahead and do number 6, and then the other 3 can be for you to do. Okay, so we have some fractions here, which makes it a little bit annoying. Here's my X club. So identify any of your other X's with the symbol in front. And then I have a constant club here and here. Okay, and unfortunately, they don't have common denominators, so it's a little extra annoying. So we have negative 3/4 plus a 7/8. I'm just going to make a note that if I multiply by 2 over 2, this is 6/8. Okay, and make sure you write it as negative. You don't want to lose that sign. Okay, so we have a negative 6/8 and a 7/8. Different signs subtract, so I end up with a 1/8 X here. And then I have my 2 constants that happen to be fractions also. We're going to have to make common denominators because we're joining these together. And so I know half. So thirds, let's go ahead and make everything 6. So the half turns into negative 3/6, and the 1/3 as 6 ends up being negative 2/6. Okay, by multiplying by 2 over 2. And so we have a negative 2/6 and negative 3/6 puts us at a negative, okay, or we're adding a negative, or just writing minus. So we have a negative 5/6 as a constant, okay? And so there's my simplified. So that's a little trickier there with having to generate common denominators. So just be careful with those with 7 and 8 as you go. Okay, so those ones will be your homework to play around with and see how you do. All right, so now we're on to the distributive property, which is pretty quick. And there's no fractions in this one, which is nice. So just remember, step 1 is going to be, if it is subtraction, to KFC it right away. If it's not subtraction, though, it's an addition, you're just going to draw your arc to show you're distributing the 2, and then you go ahead and multiply it. And I would practice saying it with your words. 2 times negative 3x is negative 6x, plus 2 times 5 is 10. Okay, and then you're all done. Let's jump down to 12. Okay, we're just distributing this way. It's the same thing, though. And to be honest, I mean, you really could put the 4 here. It really doesn't matter. Okay, if that helps you to distribute it, that's very okay for you to do. So we have a negative 8x, 4 times negative 2, and 4 times a negative 7 is a negative 28. Remember, you can't have a parenthesis here, so you do have to make sure your final answer says minus 28. okay, at the end instead. Okay. All right, let's go ahead and take care of number 10 together. So we're going to go ahead and distribute the 6 out. So we have 6 times a negative 4x is 6 times 4 is negative 24. Okay, and 6 times 3 is 18y. Okay, and there we go. Okay, so you're going to go ahead and you have 3 negatives there, sir. Don't forget right away, KFC those as you go. Okay, so you have 13, 11, and 14 to do. Okay, all right, 15 and 16, and that's it. 15 shows 2 sides of a triangle. It says the perimeter is this. So here's our perimeter. Write an expression in simplest form for length 3. So basically, they're giving you the perimeter and 2 sides of the triangle. So if I draw this out, they're saying that side 1 is 2 times the quantity of a plus 3. Side 2 is 3a minus 1. And you don't know what the last side is, but they are giving you the total perimeter. So you're going to want to join these together to then see how much more you need to make the perimeter. And so at this point in time, we have 2a plus 3 for that side, plus 3a minus 1 for the other side. I'm going to KFC that right away. We have to distribute first. And so I have 2a plus 2 times 3 is 6, plus 3a plus 1, and then now combine like terms. So here's my a club. Make sure you include the symbol there. And then I have a positive 6 and a positive 1. Let's join them all together. So I have a 5a plus 7 so far. And remember, my total perimeter is 6a plus 3. So what is my last side? Well, if I added 1a, that would get me my 6a. And I end up with a 3, so I'm going to have a negative here. So how do I get to a 3? Well, 7, 6, 5, 4, 3. So I must have a negative 4. And so here is my third side, just a minus 4. So if I joined all those together, I would end up with a grand total of 6a plus 3. Okay. All right, so there's my work for that. Number 16 will be for you to do. It's just like the notes. If you need any help, make sure you let me know.